Hello everybody and welcome to Pankaj's Echelon tutorials, and today we are going to start with uh, next topic on the same chapter, that is uh, properties of waves. Okay, and this is I suppose this is video number 3 if I'm not mistaken. Yeah, this video number 3. So in the first two videos, we discussed about the waves. Okay, what are waves, then what are the different properties of waves, the basic properties, the wavelength, the periodic time, then the frequency, the speed of the wave, etc. Then we studied what are the two types of waves, or what are the different types of waves. Okay, there's something called longitudinal waves, there's something called transverse waves. Okay, all that we have studied in the first two videos. Okay, now we are coming to the video number 3, and this is in this video, I want to start discussing on wavefront and its types. Okay, so what is a wavefront? First of all, let me talk about it. Now, we have talked about what is a ray of light. Okay, so ray of light or light is an example, but a wave can be a wave of a light also, it can be a wave of sound energy also, it can be a wave of any other energy also. Okay, so wave is a general word, and light, sound, electricity, magnetism, all this can be considered to be traveling in the form of a wave. Okay, so any wave in general, and in particular the light wave, okay, we have seen that we always show it with the help of a ray. Okay, so suppose you want to show a light, okay, moving from one direction to another direction, you show it by this way. Okay, you draw just a ray and you show that this is the direction of the light. Okay, but then this is only a single line which is telling you this is a beam of light, or this is the direction of the light in which it is traveling. Okay, actually speaking, the light is traveling in the form of wave. Okay, so what is a wavefront? If you draw certain lines, which are exactly perpendicular to this ray of light. Okay, now can you see this red lines that I have drawn? These are the lines which are all perpendicular to this yellow line. Okay, or yellow ray. Okay, all these are perpendicular. So this set of red lines, is known as a wavefront. This is nothing but a wavefront. Actually, what is a wavefront? If you see this definition, you will come to know the imaginary straight line joining the particles of a wave which are in the same phase is called a wavefront. Okay, so suppose you take a wave like this. Okay, suppose you take a wave like this. Now these are the points which are in same phase. Okay, let me name them as A, B, C, D. Okay, so A, B, C, D are all the points which are in same phase. Same phase means they are at the same level from the undisturbed position. Okay, so if this is the undisturbed position, these are the crest. Then all these crests are at the same level from the undisturbed position. That is this line. Okay, so all these points, if you join them by a line, okay, if you join them by a line, you get one wavefront. Okay, you get what? One wavefront. So this line joining all these points is just a one wavefront. Okay, that way, as the wave is made up of many, so if I try to draw a three-dimensional figure, you will get a similar wave behind this wave. Okay, and one more behind it that way. Okay, so if I keep on joining this crest of all this, I will get lines which are parallel to each other, and this is nothing but the wavefront. Okay, so wavefront are the imaginary lines, straight lines joining the particles of a wave which are in the same phase. Okay, so it can be the crest also, it can be some other points also. So all these lines, which are joining the same phase particles, okay, the particles which are in same phase will form a set of parallel lines which is known as a wavefront. Okay, so if you want to just imagine that way, suppose this is a wave. Okay, and it is traveling from left to right. Okay, then this wave can be shown just in the form of a wave diagram like this. Okay, so this is known as a wavefront. Okay, now can you see this particular example that this slide you can see? This is an example of a straight wavefront. Okay, that I have drawn already over here. Can you see? This what I have drawn is same as this. Now this is the picture of the wavefront that you can see when you happen to create a straight wavefront in a ripple tank. So on the screen below the ripple tank you will see such a picture. Okay, so this is an example of a straight wavefront. Okay, now straight wavefront will be formed when you use a horizontal bar oscillating pedal. Okay, when you use a horizontal bar or a rectangular long bar as a oscillating pedal. Okay, all this we have talked in the previous video. What is a oscillating pedal? There are two types of oscillating pedal. One is a rectangular shape, one is a spherical shape. Okay, so when you use an oscillating pedal which is of a rectangular bar shape, okay, then you will get a straight wavefront like this. Okay, but instead if you use this type of oscillating pedal, it's known as a spherical. Okay, spherical shape ka oscillating pedal, and if you use that to create waves, you will get this type of a wave. Okay, these are known as circular wave pattern or waveform front. This is known as circular wave front. Okay, so I hope now you are okay. This is circular wave front. Okay, circular wave front can be drawn like this, or it can be in general drawn like this. Okay, these are circular wave front. Okay, and one more thing, a line which is perpendicular to all this wavefront, cutting all this wavefront at 90 degrees. This is known as a ray of light. This is a ray of light. Here also the ray of light will be something like this. Okay, this is the ray of light. Okay, so any ray of light, okay, can be thought of as a wavefront also. Only thing is the wavefront will be in the perpendicular direction to the ray of light. Okay, it's if it is a straight wavefront, then all these wavefront will be straight lines parallel to each other, and if it is a circular wavefront, then all these wavefront will be the arc of the concentric circles. Okay, so that is all about this wavefront and the two types of wavefront, that is circular and the straight wavefront. So this is the definition of the wavefront. Okay, you can see this is the definition of the wavefront. Then here it is written that there are two types of wavefront. One is which is straight. Now this is a diagram which is showing you straight wavefront, and this is the diagram which is showing you circular wavefront. Okay, so I hope this two types of wavefront now you are okay with. Okay, now let us proceed. Now wavefront and a ray. Now as I told you, wavefront and ray are related. How you know? Suppose these can you see these tick marks that I have done? These are the wavefronts. Okay, straight wavefront. And if I draw a red line which is cutting all this wavefront at right angle, okay, then this red line is known as a ray of light. So that way a ray of light and a wavefront are associated with each other. Here also you can see this is a ray of light. Okay, and this wavefront that you can see is a circular wavefront. Okay, so the ray of light will be cutting all this wavefront at 90 degree. Is that clear? So that's the meaning of a wavefront and a ray. Both are one and the same. Okay, only thing is when you want to show wavefront, you'll have to draw many parallel straight lines or parallel arcs. Okay, and if you want to show a ray of light, you'll have to just show a single ray. Okay, that's it. Now coming to the three properties of light, or rather phenomenon of light. Okay, so three important phenomenon of light. Okay, there are many phenomenon of light, but we are going to study these three. that is something called reflection, and then you will be having something called refraction, and then you will be having something called diffraction. So three important are reflection, refraction, and diffraction. Okay. So these three important phenomenon of light we are going to study in this IGCSE syllabus. Okay. So first let us talk about reflection. Now what is reflection? Now rather, I'll take you to that slide where I've written all these things. Okay. Yeah. Coming over here. Yeah. This is that. Now these are the three important phenomenon of light. Okay. The three important phenomenon of light are that you have to study. Okay. One is reflection, refraction, and diffraction. Okay. Now before we start with this reflection, refraction, and diffraction, okay, let me tell you certain uh, properties and certain concepts of a light wave. Okay, light wave in particular. Okay, I am not talking about any wave, only light wave in particular. Okay, so important concept of light wave is what? Number one, light always travels in vacuum as well as in medium. Okay, you know that light being a transverse wave. Okay, light is a example of transverse wave. So it is going to travel in vacuum also, and it is going to travel in medium also. Okay, so that is one thing that you should keep in your mind. Second thing is the frequency and the time period are inversely related. Okay, or rather I will not put that proportionality sign, I'll put equal to sign only. Okay, because in fact frequency is equal to 1 upon t. Okay, so this is that second point that you have to remember. All this relationship between the frequency, the time period, the velocity, the wavelength, and all that, you have to see what is the relation between the two. Okay, any two of them. So frequency and time period, they are reciprocal of each other. So frequency is f, time period is t, f is equal to 1 by t. Example, if the frequency is 5, then the time period will be 1 upon 5, that is equal to 0.2. Time period is measured in second, frequency is measured in hertz. Okay, so if the frequency is 5 hertz, then the time period will be 0.2 seconds. Okay, so this is that relationship. It holds for any value of f and t. Second relationship is v is equal to f into lambda. V is the velocity of the light wave. Okay, so velocity of the light wave. Now this is in general for any wave. Velocity of any wave is equal to the frequency of that wave multiplied by the wavelength of that wave. Okay, so this is that another relationship that you should remember. Velocity is frequency into wavelength. Third is this relationship where the frequency is inversely proportional to lambda. Okay, it is not equal to but inversely proportional. What is the meaning of this? If the frequency of a wave is more, then automatically its wavelength will be less, and if the frequency is less, then the wavelength will be more. Okay, this I can explain you like this. Now here you can see this is wavelength. Okay, suppose this lambda is say 2 meters. Okay, and this is one wave. Okay, so frequency is 1 hertz. Right, now suppose I draw, okay, three waves, 1, 2, and 3. Okay, from here to here this is one wave, from here to here this is two wave, and from here to here this is three waves. Okay, so these are three waves I have drawn, and this distance, okay, okay, there are three waves, so frequency will be 3 hertz. Okay, frequency will be 3 hertz. Agreed. Now if you see this two, here the frequency is 1 hertz, here the frequency is 3 hertz. So here the frequency is more compared to this. Okay, so when the frequency is more, can you see that the wavelength of this particular wave has decreased? These are both the same wave. Okay, both are same wave, but in this case, that is A case, the frequency is 1. Okay, and in B case the frequency is 3. What is frequency? It is the number of waves in passing through a point in a given time. Okay, that is known as, or rather in 1 second. the number of waves passing through a point in 1 second. That is known as frequency. So suppose in 1 second this wave travels this way. So there is only one frequency. Okay. Here in 1 second it is traveling this way. So the frequency is 3. Okay. So when the frequency is increasing, can you see that the wavelength is decreasing? Now here the wavelength was this much. From here to here it was 2 meter. Now here it has become less. From here to here this is quite less than 2 meter, isn't it? So when the frequency is increasing, the wavelength is decreasing. Say the wavelength is supposed from 2, it has come to say 0.7 meter, something like that. Okay. So frequency increases, then the wavelength decreases. So that is this particular relationship which is showing that frequency and wavelength are inversely related. And this last relationship is between velocity and the wavelength. So this is a direct variation. So when the velocity of the light or any wave for that matter increases, the lambda or the wavelength also increases, and vice versa. If the velocity is decreasing of any wave, then its wavelength is also decreasing. Okay. Here I will show you by showing you this example. Now this is a wave. Okay. Now can you see till here, till this point, the lambda is more. This is your lambda 1. Okay. And here now, here this is the lambda 2. Okay. This is lambda 2. Now can you see here the wavelength is more and here the wavelength is less. Now what is happening over here? This is a wave which is traveling in this direction, and while traveling in this direction from left to right, its speed is decreasing, its velocity is decreasing. So when velocity decreases, the wavelength also has to decrease. So I have shown here, this is the wavelength over here, this is lambda 1, and this is the wavelength over here, lambda 2, and I am telling you lambda 1 is greater than lambda 2. Okay, because this wavelength is bigger than this wavelength, so lambda 1 is greater than lambda 2. Now this implies that v1, that is velocity of the wave in this part, is also greater than the velocity in this part. Okay, so this is velocity, v2 is the velocity in this side of the this thing, and on this side the velocity of the wave is v1. Okay, so v1 will be greater than v2 in this case, and lambda 1 will be greater than lambda 2. Okay, so this is shown here by the diagram. So whenever a light is traveling from uh, uh, higher speed, and it is changing its speed is coming down, then what will happen? The wavelength will also be reduced. Okay, so when the velocity decreases, the wavelength also decreases, and when the velocity increases, the wavelength increases. That is what you have to remember. Okay, so these were the two concepts of light. Coming to the third concept, in a given medium. So suppose you have a fixed particular medium. Suppose you are into a glass medium, or you are into a water medium, or you are into an air medium. So we are sticking to one particular medium. So in a given medium, fixed medium, the light of a the light always travels with a same velocity. Okay, so in a given medium, as far as the medium is not changing, the light will travel in that medium with a fixed velocity. Okay, now that velocity can be different depending upon the medium. Okay, but as far as the medium is fixed, the velocity of the light in that particular medium will remain same. For example, the velocity of light in air will be always 3 into 10 raised to 8 meter per second. But in glass, the velocity of the light will be 2 into 10 raised to 8 meter per second. Okay, so when the medium changes, the velocity of the light changes, but in a given medium, the velocity of the light will remain same. Okay, so that you have to remember as the third point. The fourth point is, as the medium changes, the light speed is also changing. Now fourth point is very important. Now see, here I have told you that the light at this side of the partition is traveling with a high speed, and at this side, on the right side of this partition, the light is traveling with a lower speed. Okay, so what is happening? The velocity of the light is decreasing. Okay, so When this happens, this happens when the medium changes. So definitely on this side of the line, okay, on the left hand side and on the right hand side of this particular line, the two mediums are different, okay, and that is why the velocity is changing. Here the velocity is more, here the velocity is less, okay. So whenever there is a change in medium, there is a change in velocity of a light, okay. And when there is a change in velocity, because velocity is directly proportional to the wavelength, there will also be change in the wavelength, okay. So when the velocity decreases as it travels from one medium to another medium, then its wavelength will also decrease, okay. And if the velocity is increasing, if it is traveling from one particular medium to another particular medium, then its wavelength will also increase, okay. So as the velocity decreases, wavelength decreases. As the velocity increases, wavelength increases, okay. So this increase and decrease in the speed and the wavelength of a light wave happens because of the change in the medium, okay. Now this property of changing the speed or the velocity of the light when it is traveling from one medium to some other medium is termed as refraction. This is known as refraction, which we will be studying in a near future, right? So that is about refraction that you should understand and know. Then let us talk about next concept. Light travels always in a straight line, and this particular thing is known as rectilinear propagation of light. See, light, will always travel in a straight line unless and until by some obstacle or by some artificial means you are changing the direction of the light. That is a different thing. But otherwise, if the light is allowed to move freely, it will move in any vacuum or in any medium in a straight line. Okay, it's going to follow a straight line path. It will not follow a zigzag or a curved path or nothing like that. It will travel always in a straight line. This property of a light is known as rectilinear propagation of light. Okay, so this is also you should remember very well, the fifth point. And the sixth point is when a light ray hits an opaque surface. Now see, light travels in the form of a beam and it travels also in the form of a wavefront. Okay, so when a wavefront of a light or when a beam of a light or when a ray of light is hitting some opaque surface, okay, what is happening? That beam of a light or that wavefront is sent back or thrown back in the same medium. This particular phenomenon is known as reflection. So what is reflection? Reflection is defined as the throwing back of the light, okay, into the same medium on hitting a opaque surface. So that is reflection. So refraction, I told you what is it. Reflection, I told you what is it. Now let us talk about what is diffraction. Diffraction is due to the bending of light, okay, along an edge or a narrow slit. Now, diffraction is not a automatic change in direction, or it is not the change in direction of the light because of the light traveling from one medium to another medium. No, that is refraction. Diffraction is again the change in the direction of the light, that is the bending of light, but this time it will be in the same medium, okay, but when there is a edge, okay, a corner coming in its path, or when there is a narrow slit through which the wave has to pass. So when it is passing through a narrow slit or when it is passing over an edge means like a mountain top, okay, it has a very sharp edge. So along that, whenever a wave is passing, then there is a diffraction that is taking place. Diffraction is also bending of light, but that diffraction is along the edge or a narrow slit, okay. And diffraction can happen in one particular medium only, okay. That way it is different from refraction, okay. So I think that's all for today. I wanted to just introduce you to the three concepts. First of all, that is reflection, refraction, and diffraction. Now from next lecture onwards or in the next video, I'll explain you the reflection, which is explained by ripples. Can you see here? The topic is already ready with me. Okay, this topic we are going to start with. Okay, so reflection we are going to explain or we are going to understand with the form of the ripple tank, okay, experiment. Then same way we are going to understand what is refraction, and same way we are going to understand what is diffraction. Okay, but all these are to be coming in the coming video. So for today, I want to wind up my video here and here itself, and I request you to subscribe my channel if at all you like it. Okay, so that I can make more and more such videos on various topics on maths and science for IGCSE students. Okay, so that's all for today. Goodbye. Take care, all of you. See you.